Sometimes you have a vision and an idea, and although you can plan as much as you want, you're not going to know if it works out until you try.
Oh, it's so nice.
So you chip away,
Schmick.
and you learn something new. And over time, each piece comes together. Sure, there may be challenges,
Oh my God, my heart stopped.
but through mistakes and a lot of patience, that vision starts to come together.
Oh!
But we're not done yet.
Hopefully this isn't damaged.
Probably going to make quite the mess.
I was feeling really good today. I'm not feeling good anymore.
So the first piece of tech to go into the right panel is a Stream Deck Plus. I bought this because the knobs allowed me to control independent application volume, and the touchscreen cycles the multiple pages of commands. But if it doesn't fit into the desk, it's useless to my setup. Thankfully, in that video, we could see the circuit board would fit, so now I need to try to get it out. I originally thought bending back these metal tabs would release it from the housing, but after pushing from the front, I realized it was all one big module, but something was holding it back. So I removed the knobs to get a closer look.
Oh no. This glass paddle here on the touchscreen actually connected. Uh-oh. Alright, that's this board here. Lift up, pull back. I did not expect to find that. Oh, what the whole thing's just a screen. So the buttons aren't individual screens at all. I need to somehow get this out.
I used my wife's hairdryer to heat up the adhesive to separate the touchscreen element from the housing, and had to be careful to not rip the two pieces apart because the ribbon cable had to be fed through a small pass-through.
Oh, I did it. Hopefully this isn't damaged. I need to recreate this little bezel that's on the inside here. Problem number 2, with this original faceplate, these buttons here are flush, but the knobs are curved, right? It's like a recessed section. And so this PCB needs to be lifted up. That's quite a tricky one.
Oh, all right, this base. When I added the standing desk legs, it really took the desk to new heights. I'm sorry, I had to. But the control unit was only temporarily mounted to the front of the desk. So let's take it off and see what we're working with.
Hey! Oh, it's off. Oh!
It just bends the one that you're pressing.
Can I do that? I don't know if I can do that.
You can pop that out. Oh, come on. Well, that was a very simple one. Final piece of tech is a USB hub to allow me to easily plug devices into my computer. Although the side ports will be blocked, I can use the rear ports like the HDMI to feed the output to the touchscreen that I mounted in the center of my desk.
Is it a pull? A push? It's all metal. There's still plastic underneath it? You trolling me? That bit's just gotta stay. I can't get it off.
It was really cool to see a laser cut piece of acrylic used for mounting the circuit board in the enclosure, because I have to cut similar holes in my panel for every port, knob, and button. And so let's start with the Stream Deck. How does a free Raspberry Pi Pico sound? Well, in today's sponsor PCBWay's KiCad Open Source Design Contest, you can score a Raspberry Pi Pico as a participation award. And if your communication or automation project is picked as a top 10, you get a Raspberry Pi 5 4GB and $100. You have until June 2nd to enter. Thanks to PCBWay.com for sponsoring today's video. Okay, so I took some photos of the face panel and I can then add them into Inkscape, which is free vector graphics software. With a pair of calipers, I'll take a measurement of this rectangle and then I'll recreate it in the software and scale the photo to match. Now I'm simply tracing the image.
I'm not a designer, but I really like designing things.
You might remember seeing when I unboxed and set up this new laser cutter that there was a dent in the front panel. Thankfully, Creality shipped out a replacement piece, so now it's fixed. However, I am still concerned with the amount of visible blue light through this laser shield, including the literal hole in the side. So I'll still be looking away and wearing glasses during operation.
That is so good.
We can fine tune that with wood. Oh no, these mounting holes. They need to be like raised so I can put the screws through them. So I can't have this come out here. I have a bunch of these connectors from when I did the lighting on the desk, but unfortunately they're not the right spacing for this plug. So on top of designing and 3D printing new mounts for the Stream Deck, I have to figure out a different way to raise the knobs.
Time for the USB hub. I want the side of this mount to kind of come up and clamp it on both ends. Be like that. Just 2 pieces.
And I love Tinkercad. This is free 3D design software. I simply take the measurements I need and then either add shapes together
Nice.
or subtract shapes from one another.
I like that. Oh, that fits.
Now, if we have a peek under the microscope, you can see I've added a little slot for the circuit board to perfectly wedge into. This will also stop the bracket from sliding and colliding with other components on the board.
I really think if there's a way to extend these knobs.
So this like D shape in the knob would normally go down onto the encoder with the matching, right? What if I made copy, paste, so you got like the normal encoder and then you 3D print like a little mini cap that will go onto it and then have a new encoder bit that continues and then this itself can go onto the extended bit. With 3D printing, it's rare I get parts fitting on the first try, simply because the plastic is squished and cools and warps within fractions of a mil. And these are the tolerances I'm trying to find for a nice snug fit. However, with the laser cutter, working in only 2 dimensions, it's a lot easier for parts to line up. Unless you plan to flex them. So for the standing desk, I'm going to add holes where I think the buttons will be so I can ensure the part is lining up correctly. And then I'll add a cut to relieve some strain from when I try to flex the panel.
The left-hand side. Perfect. All right, 1 millimeter. All right, that's good.
I did a few tests with black acrylic, but I couldn't press the button without it breaking.
Oh, I just 3D print a little extension.
Yeah, this is actually a pretty simple idea. 3D print a bit of plastic to reduce the distance the acrylic has to flex. At this stage, I'm in my flow. I'm taking measurements, making fine-tune adjustments, and just dialing everything in. Until I realized I forgot to do something. Josh, truth, big problem. It's not going to fit. I think I was going for the entire panel width and not the segment between the metal aluminium extrusions. So these circuit boards are like just overlapping. I was feeling really good today. I was like, it's going to be in. I'm just going to have to like make some little tweaks. I could cut the PCB shorter. It's going to be tight, but we can make it work. To make these standing desk controls shorter, I need to remove the USB charging port. Bit of flux, solder wick, but then I realized, why bother? Just like in the past, I had to head in town to get a CO2 laser cutter to cut the final panel, as my blue diode laser machines can't cut this transparent material. Okay, so what I'm gonna do now is something I haven't done before. I need to grind just a segment of this panel so the USB ports can kind of sit flush. You may remember that when I installed the touchscreen, there's a ribbon cable that was in the way, and so I had to cut wider to go around it. And then I saw a comment that suggested grinding down or just sanding a section of the acrylic so it doesn't have to cut all the way through, but it could allow things to get closer to the surface. Brilliant. So although I could cut this notch off this circuit board like I did with the last one, over here where the SD card is, I can't cut that one off. It's just like extra chungers. So I put out this little grinding disc. I think it's the right one, and it's probably gonna make quite the mess. Oh, that's in. But the very tip there, slightly not touching. Wipe marker, put tape over it. Teeny tiny dot of red. This is quite hazy here. I'm trying to buff it out. All right, today's the day. Putting it all together. I've spent a fair bit of time making these little brackets. And it's a Stream Deck, which I thought would be the easiest one, but it's actually been the most tricky. So for the first one, I thought this would be easy. I can just like place a big bracket over the back, put some pressure on the circuit board, and have mounting holes between. But then I realized that the longest screws that I have barely even fit through that support, let alone to get a nut on the other side. And so I come up with a new plan to kind of like put the bracket underneath the knobs. And so this would work with the length of screws that I had. However, if I pressed the top buttons of the Stream Deck, it would move back because nothing was holding it at the top of the faceplate. And then I realized that when I have to put the touchscreen element back in, that ribbon cable will collide. And so I made another version where it has a cutout for the touchscreen ribbon cable and then an extra block on the side here. So when I press the top buttons of the Stream Deck, it doesn't move anywhere once it's all bolted in. It's such an iterative process to work with existing tech to try and retrofit custom brackets to a circuit board that wasn't meant to be mounted in this way to make it mount this way. It's time to 3D print the final ones in transparent PETG filament. This way they're not going to stick out when I screw it all together into the desk. I got it! With brackets holding the circuit boards in place and risers bridging the gaps to the panel, it's time to test if it works. Yes! Okay, let's check the screen. Swipe it. Haven't broken it? That's good. So unplug that in to the USB hub. Now there's no chance that the USB cable from the hub is going to reach my computer. So I bought this extension cable that will extend the cable to my computer. No. Bro, I can't if this just doesn't fit. Oh, we're working with fractions of mils. And I think these screws on the bottom encoders are touching. That's the smaller size. I can't even get a nut on it. Oh, I've got chills. I don't know what happens. Like, I know what it's gonna look like. The custom knobs. I have a heap. Oh, sheesh. Dude, come on. Like, that's wild. Yeah, I'm stoked. I did accidentally break number 1 on the standing desk button. When I was testing the 3D printed risers, I was pushing them pretty hard, so thankfully 2, 3, and 4 still work. If I'm being honest, I'm not stoked that I couldn't get straight lines with the rotary tool, but it is like the 3rd time that I've used one of those tools, so I need to be forgiving of myself there. And overall, for my first time at like pulling tech apart, 3D printing custom brackets and laser cutting panels, I am pleased with how the vision in my head has transferred into the real world, especially with how I went to plug an SD card in yesterday to transfer footage and it just popped up on my computer. I was like, that's wild. I've also been trying to recreate my speaker stands after the last one broke. I think I've hit the sweet spot for TPU filaments. If you want to download the files for the speaker stands, all parts in the desk, including the measurements and drawings for the desk itself, link is in the description below. You can find them there. There are gaps, so I can still add some switches and other tech in the future, but I think I need to spend some time on cable management and just tidying up some small details. And that brings us to the hole in the desk, which is for this start engine button, which when pressed will power on my next project. Man, that's so cool. Really do not expect it to take this much time at all.